in July, remember what happens? All these zones shift. Let me quickly toggle back just to show you this. Look at the position of the intertropical convergence zone close to the winter solstice, January. Here's the equator. It's south of the equator. Okay? Oops. If we go here, now we're into the summer, into July, look where it is. It's north of the equator. So this is showing you the sun's dragging these things both north and south. So let's stay with July. And what you'll see here is you don't see an Aleutian low. It's gone. It tends to disappear. It might move way up into the Arctic, but it's kind of gone. So what happens out here is, look what's happened. The Pacific high has really moved to the north. And if any of you guys have ever spent any time in the northwestern part of the United States or in British Columbia, like Vancouver Island, the summertime can be beautiful. And it's because the subtropical high shifts to the north and gives places like Seattle, Portland, Oregon, really nice, clear, dry, warm weather. All right? Same with the Bermuda high. It tends to move a little bit north, and its clockwise circulation around here moves all of that very warm, moist air onto the land. Anybody spent time in the east of the United States in the summer? No. Come on, somebody's been in the east in the summer, right? No?
Oh, yeah.
Okay, whereabouts were you?
North Carolina.
So how would you kind of describe your summer kind of weather?
A long time ago. I think there was a point where it rained a lot.
Yeah, it's
I'm pretty sure that was towards the summer, fall.
Well, I was thinking of, so I've spent a lot of time in the east. You ever heard the term muggy?
Oh, humid.
Hot and humid, and that's because this very warm ocean water has a lot of water vapor on it. This Bermuda high is blowing that on into the eastern half of the United States. And so there's really high, very high humidities in the eastern part of the United States in the summertime. And that's why you would feel that out of North Carolina. Now, a very interesting feature develops in our area here in the summertime. And we'll talk about this more. I'm going to do a case study on this later on in the course, but just to introduce it here. This is called a thermal low. Thermal low. Low pressure developing from heat. Land is heated up, heats the air above it, causes air to rise. Think of this as a plume of rising air. And so if you got this continuous plume of rising air over a hot land, it creates low pressure below it. This becomes a semi-permanent to permanent feature here in the Southwest, probably starting by mid-July, and it will last through about mid-September. And this is what's going to cause our monsoon. We'll talk about that later on. So this thermal low will develop only in the summertime when the ground is at its maximum temperature, and like I say, about mid-July to about mid-September. And more on that later, okay? So there you go. Your summer positions, intertropical convergence zone has moved to the north. Subtropical highs have moved to the north. So much it's even displaced the subpolar low. There's a little bit of a subpolar low left over Greenland. So all these zones have shifted to the north. Now, this would be kind of like an introduction into meteorology here a little bit. When, as I said before, air masses of different temperature and different humidities don't mix. So a typical setup in the wintertime in North America, and this is just one example. It's not like this is stationary or stays like this all the time. But this has happened a lot this winter. We get this cold, dense, dry air out of Canada moving south. This is relatively warm, relatively humid air down here. What happens when they meet? A boundary forms between them because they don't mix. Air masses at different temperature and moisture don't mix. So this is a boundary. Just think of it as a boundary. That's all I got to think of it as. But we do have different names for these boundaries depending on the direction they're moving. So we start over here. This is a boundary that has these sharp teeth on it. What this is telling us is that the boundary is moving. And the boundary is moving the direction these teeth are pointing. So this boundary is moving this direction. And what it means is that this cold air is moving and advancing into this warm air. We call this a cold front, and I call it a polar front here. I mean, generically, it's a cold front. That's what we call it. We call something a cold front when cold air advances into warm air. Now look at this one. It's a little different. We've got these rounded symbols on one side. This is called a warm front, only because warm air is advancing into the cold air. Still, it's the same boundary all along here. It's just that here, the cold air is moving into the warm air. Here, the warm air is moving into the cold air, so we call it a warm front. Now, we can also get a front that's called a stationary front. It's not either, cold air is neither advancing, the warm air is neither advancing, the front's staying put. Let's take a look at what's actually happening today. Okay, this is what we call today, this is the current surface analysis for the United States. Okay, it's a lot of information on here, even though this one's actually fairly simplified. So let's take a look at it. So this is what's really happening. Well, look at this. It doesn't look that much different from what I just showed you. We've got a cold front all the way down into here. All right, so similar to what I just showed you today, cold, dry air is advancing into warmer air here. Okay, and you can tell that. These are called station models. Okay, these are cities, and we put numbers around them. This is a very simplified one. I can tell you this number in the upper left is the current air temperature. So we're looking probably Knoxville, Tennessee here, currently 52 degrees, back in the cold air. Let's look down here to Columbia, South Carolina. Anyway, it's in South Carolina, 67. 15 degrees warmer on the warm side of the cold front. Okay, so you can actually see the difference here. All right. So anyway, this cold front peels around like this, and then look at this kind of front. Rounded, sharp, rounded, sharp. I bet Ruben knows what this is. What kind of front is it? Remember what kind of front that is? You took meteorology, right?
Yeah. Well, you got a cold front and warm front this one, so it's a cooler front.
This is stationary.
Stationary.
Okay, stationary front. So this means neither the cold air advancing into the warm air, nor is the warm air advancing into the cold air. And you can see where it is. You see we got this front stretching right across southern part of Arizona. Remember earlier today we saw all those clouds in the area? Fronts create lift. And again, whenever we get lift, cool, condensed clouds. So part of the reason it's cloudier down in southern Arizona today is because of this stationary front. So anyway, we'll be looking at these more, but I just wanted to show you the actual depiction of fronts boundaries today, in today's weather map.
That was 2 hours ago.
Yeah, well, let's actually talk about that. It's a good time to bring this up. We really need to know what time this was taken, and this is called a synoptic map. One of the things the synoptic map will do, every bit of data you see here was recorded, bam, at the same time. So what value would it be if, this is Phoenix, Arizona right here. What if Phoenix, Arizona, which they take the weather at Sky Harbor Airport, they go, I don't really feel like I'll report my weather in 15 minutes. No, you do it right now, because then we can make some sense out of all this. So the way to tell the time on this map, 16Z. We've got that number 16Z up here. 16Z. Okay, what's the Z for?
Zulu.
What's that?
Zulu.
We call it Zulu time.
Also known as UTC.
So now it's clear as a bell. Yes, Zulu time is also UTC time, which is still like most people still universal train, whatever. But here I want to tell you, I'm going to make it easy for you. Zulu time, London, England time. All right? London, England. Some people will say Greenwich, but London is the same basically as Greenwich. All right. So in other words, all our synoptic weather maps here are taken at a London time. Okay. Now what about that 16? So we know what time zone we're talking about. But now the 16. For those of you folks that are not familiar with the 24-hour clock, what you got to do with that 16 is add 2 zeros. So yes, 1600. So let me just point something out here. Midnight would show up like that. You'd add 2 zeros to it, that's midnight. 1 a.m. would show up as 01, which is really 2 more zeros, so on and so forth. And we go all the way up to 2400. That's the 24-hour clock when we start again. So we don't have AM and PM on this. So 1600 would be what?
4 p.m.?
4 p.m., right. Well, that's kind of helpful. 4 p.m. in London. So now we got to figure out what time was this taken in Arizona? What time zone are we in here?